This video is actually about a little bit of algebra. A lot of you are having trouble with constant of integration, what to do with a constant of integration at a particular point in the process of manipulating an equation so that it's in the form of an answer. So here I'm going to go through how to deal with that constant. Notice that I have not explicitly defined the function f of x. It's just some function of x because it doesn't matter. This will hold true regardless of what this function happens to be. So if I separate the variables here by dividing both sides by y squared, first of all, I'll get dy over y squared. And then if I also multiply both sides by dx, I'll get f of x on this side still times dx. And it's this equation now, and it's the equation in this form that I want to integrate. This is the same as, let me change this a little bit. This is the same as y to the power of negative 2 dy equals the integral of f of x. And integrating means adding 1 to the power and dividing by that new power. And of course, there's a constant here. We've talked about this a little bit. We're going to get this integral when we integrate the right-hand side. We're going to get the integral of f of x dx. And there's going to be a constant there. And as I've said in other videos, we can absorb this constant into this one. So if I call this one constant 1 and this one constant 2, and I subtract constant 1 from both sides, I get negative y to the power of negative 1 equals the integral of f of x dx plus some constant. C2 minus C1 is still some constant. So I can just write it there. I don't need to write it on both sides. All right, now what does y to the negative 1 mean? It means 1 over y. Of course, it's negative here. That's still going to be equal to whatever I get on this side, the integral of f of x dx, plus some constant. Now, when I take this integral, it's going to be a different function, but it is going to be a function. And so once I've done that and added c to it, I need to get this into the form y equals. Right now it's negative, and it's 1 over y. So I need to do some algebra here. There's a nice little shortcut that says a over b equals c over d. Those are all real numbers. Then you can, by algebraic manipulation, just write b over a equals d over c. You can just flip both sides. You can get away with doing that. And that's what I'm going to use here, just kind of as a shortcut. So I'll erase that. We don't really need it. And so what I'm going to do is I'm going to write, first of all, I'm going to put this over 1, and I'm going to rewrite this as negative y over 1 equals 1 over the integral of f of x dx, whatever that turns out to be, plus the constant. Now notice that the constant has come down to the denominator down here. I cannot just say instead plus c out here, because although the constant of integration is unknown, it is a constant. It is a fixed value. We don't know what the bounds, the limits of integration here are, but once we did, and this is a family of functions. I mean, you could argue this is a family of functions. This could be anything. But whatever it is, just moving it off to the side over here doesn't work, because now the integration is done, I have to leave that constant at whatever value it might have. In other words, I have to treat that c as though it were a known number, and so when I manipulate this equation, I have to take that into consideration. Let's assume now that, for whatever reason, there's a fraction in front of our integral, so that when we integrate, we end up with that number in front of the function that we find is our answer to our integral. Let me get rid of this. We don't need that right yet. Because of that fraction, it's very tempting to say, well, I'll just divided by 1/6. Actually, I'm going to make this negative into a positive as well now. So I've moved the negative to the right-hand side. I'm just going to move I'm just going to move that divided by 1/6 to the numerator and make it a times 6, because divided by 1/6 is equivalent to times 6. However, I can't do it this way because although it's only this integral, it's only this function here that's multiplied by 1/6. In order to do this algebraically, in order to move this to the numerator, I have to multiply the bottom and the top of my fraction by 6 each, right? By 6 over, multiply that fraction by 6 over 6. That's what gives me the 6 in the numerator. That 6 times 1 over 6 gets rid of this fraction in the denominator, but what's missing in the way I have it currently written is that this is also multiplied by 6. So I actually need a 6c here if I'm going to change the position of this, the 1/6 divided by 1/6 to multiplied by 6, then I have to treat the entire denominator with that 6, or else it changes the value of the thing in this position. So I have two choices now. I can either leave, and I think what I'll do is I'll use a highlighter. I can either leave my answer so that it looks like this before multiplying it by 6 over 6, or, and of course I would need a negative there, my answer would be something like this, or my answer needs to look like this, where since I've manipulated it so that the numerator and denominator have been multiplied by 6, 6 is just it could be any number, but that it was 6 in this example because I chose to use 1/6 as to illustrate my point. So I can either leave my answer like this with a 1/6 in the denominator and leave the c as it is. It's still in the denominator. It's not hanging out off to the side, but it doesn't have a 6 next to it. Or if I multiply by 6 over 6, my answer would look like this. So your answer needs to be in one of those two forms.